Okay, we are on page 207. And what we're going to do is we're going to try to graph this Rose curve. So a Rose curve is R equals A, any non-zero real number, times sine or cosine, doesn't make a difference. Well, it makes a difference to the graph, but like it can be sine or cosine. And then N, which has to be a non-negative integer, positive integer. So not non-negative, positive, can't be zero. And let's just do it. I'm talking too much. All right, so here we go. So I'm going to start off by graphing this, but like give it a little forethought, right? So here, n is equal to 2, so there should be 4 petals. So we don't really know what that means yet, but we kind of know what it means. So the period of this thing is 2 pi over 2, which is pi. So if I go here to pi, so this will be pi over 2, pi over 4, 3 pi over 4. It's not going to be enough. So here's 3, negative 3. So I'm going to start here, 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 and here. So how do I know this is not enough? I know this is not enough because I have a very strong suspicion that each of the little like hills of sine and cosine is actually a petal somehow on the Rose curve. We don't exactly know how yet, but somehow it's a petal on the Rose curve. So I think I only see 2 because I see like half, a full 1, and a half. So 2. I need to keep going. So what I'm going to do is go twice as far. So I'm going to go to 2 pi. 2 pi, 3 pi over 2. Here we go. So it'll be back here, 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 and here. All right. So my hand is sticking to this iPad screen like crazy. I do not know. It's like sweat, but I'm not really sweaty, so I hope it's sweat. All right. So we have this. Now, what are we going to do? First thing we need to do is you identify where this graph is equal to 0. You note those theta values. So here, 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 and here. So this is going to happen when are these? So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. 5 pi over 4, though, is the same line as pi over 4, so I don't really need it. 7 pi over 4 is the same as 3 pi over 4, so I don't really need that either. What I'm going to do is, so this is when r equals 0. So r equals 0 gave me theta equals pi over 4, and it gave me 3 pi over 4. It also gave me, I'll write them down, it also gave me 5 pi over 4 and 7 pi over 4. I got all the pi over 4s. I'm going to take those, I'm going to dot them in on this grid. So we're dotting these in. These are going to be what are called tangent lines. So tangent lines are lines that, there are a lot of things. For our purposes, they just give the graph more shape. So pi over 4, like this, 5 pi over 4, like that, 3 pi over 4, and then 7 pi over, oh, wow, bad. 7 pi over 4. Okay, so we dot those in. They're going to give it more shape. Now, what is happening? Okay, here we go. When theta equals 0, so this is the theta axis. I should have labeled that. This is theta, and this is the r axis. So when theta equals 0, where am I? Theta equals 0, r is equal to 3. So let's go over here, and when, oh, I guess I should use a different color. Blue. Okay, so we'll use blue. When theta equals 0, r equals 3. So I go over here. When theta equals 0, r is going to be 3. So I have to decide what I want to count by. I'm going to count by halves. So this is 1, this is 2, and this will be 3. Theta equals 0, r equals 3. So I put a point here. All right, what happens? Theta is going to increase from 0 to pi over 4. As theta increases from 0 to pi over 4, so 0 to pi over 4 means we're rotating this way, right? And as theta increases from 0 to pi over 4, r is going to decrease from 3 to 0. So that's what's going to happen here. So we're going to decrease from 3 to 0. So that's where this tangent line comes in. So we're going to go decrease, and then So we kind of like go in along the tangent line. As we get closer to the origin, we curve toward the tangent line, or like bend kind of in the direction of it, I guess you might say. All right, let's keep going. So now theta is going to go from pi over 4 to pi over 2. Pi over 4 to pi over 2 is, I'm going to change colors. Let me use something like sort of drastically different. So pi over 4 to pi over 2 is here. So we're rotating there, but notice r is negative. So we rotate and we're facing the first quadrant, but since r is negative, we don't draw in the first quadrant. We draw in the third quadrant, which is the only option. You're either going to draw in the first or the third quadrant. So we're going third quadrant because r is negative. And what will happen is by the time we get to pi over 2, r is negative 3. Where's negative 3? Well, this is 1, 2. It's going to be here. So I'm going to aim for that point. So if you go in along a tangent line, you come out along the same tangent line. And we're going to curl toward this. Okay, so far, so good, maybe. So now what happens? Now, theta goes from pi over 2 to 3 pi over 4. And as that happens, r goes from negative 3 back to 0. So we're rotating pi over 2 to 3 pi over 4. And as we rotate, since r is negative, we don't draw in the second quadrant. We keep drawing, basically once you start the curve, you keep a continuous curve. Instead of drawing the second quadrant, we draw in the fourth quadrant. So we start at negative 3, and we go in like this. All right, so far we have, what's going on? I'm gonna label these as this is 1, this was 2, this is 3, and then over here, it's 3, and then 2, and then 1. So let's keep track of what we're doing and when. What we're doing, when, where we're doing it. These are all like super important things. I don't think I have enough colors to keep going with this, so I'm going to switch back to blue. So between 3 pi over 4 and pi, we're going to go from 0 up to 3. So by the time I get to pi, I have to be at 3. So 1, 2, 3 is here. So I have to be here by the time I get to pi. If you go in along a tangent line, you come out along a tangent line. So we're going to come out like this. And then I'm having a really hard time making this happen like that. So this will be 4. And it comes from this part of the graph. And I think you maybe are getting the hang of it, hopefully. 5 will be here. We're going to go pi. You go theta from pi to 5 pi over 4. So 5 pi over 4, we're going to be at 0 again. So we go from here to here. Oh, that's weird the way that worked out. This is like the like 4-color theorem or whatever, and I didn't do it. I wanted to have no color, whatever, it's fine. I wanted no consecutive colors to be the same, but you know, can't win them all. So what was next? Next, I guess, is red, I think. Okay, so theta is going from 5 pi over 4 to 3 pi over 2. As that happens, r goes from 0 to negative 3. So when you get to 3 pi over 2, so you're facing the negative y-axis, but you're going to draw on the positive because you're going negative. So 1, 2, here is where we're going to get to. So you go in along a tangent line, you come out along the same tangent line. We're here, so that'll be what, 6? So 6. And then back to blue, I guess, will be 7. So 3 pi over 2 to 7 pi over 4. So 3 pi over 2 to 7 pi over 4. Oh, I forgot to keep going with my whatever it is that I was doing. The like angles going around. So, but you can kind of see, like, it's okay to like lose track of that actually, because once you get the pattern going, you're not gonna mess it up, hopefully. So here's 7. And then also, if you do not like this version of me doing this, I have other videos of me graphing rose curves that I made a long time ago, and you are certainly welcome to go watch those as well. So this will be 8 to finish it off. So that's from I can actually do this one, right? So we're rotating 7 pi over 4 to 2 pi. So that's the last rotation that we're going to have. And if you go in along a tangent line, you come out along that tangent line, and you get this. There's the 8th part. So the curve overall that we get, maybe I'll use a highlighter, like a skinny highlighter perhaps. I don't know. The curve was this. So here it is in action. There. Then you go around here. I don't even know if you can see it. This is very subtle. Here, and then up here, and then here, and then there. So that was super subtle. I don't even know if you could really pick that up. Depends on the screen that you're looking at. But anyway, that took a little while. So what I'm going to do is I'm going to cut this here. I'll come back in the next video, graph a few more of these rose curves. They're like pretty fun to graph. So we knew it was going to be 4 petals. So we knew basically you need 2 increments per petal. So if you need 4 petals, you're going to need 8 increments. 8 increments is always going to be 2 full periods of whatever you're dealing with. So I will see you in the next video when we're going to keep graphing. So see you then.